Hello everyone, today I would like to introduce you to an interest area which is observability. And if you are developing modern software, I'm sure that your architect or maybe you already talk about or start to wonder about observability. Maybe you are already integrated this in your application, and for that probably you want to check my next videos. But today I would like to introduce you. I will show you some tools, at least the name of them. I will not do any practice, but the next episode I'm sure that I will develop something that we can start to develop and learn how to implement observability in a system. So today it's about observability 101, introduction and fundamentals, meaning that from theory to practical implementation. And the question is why observability is key to modern systems, and you will see that it's really a key. So what is observability? Observability is a capability to infer, and this is quite important, the system's internal behavior. We want to see what's happening inside of a system. It's not just looking into logs or traces or metrics. It's more than that. We want to make sure that we develop our software and we use the correct tools and we capture the important logs and traces and metrics. So when some event happens that put in, let's say, in jeopardy our system, we want to be able to check what's happening, what were the causes, how was the system at the time, and that's what it's all about. It's to infer a system's internal behavior solely by analyzing its external outputs, meaning logs, metrics, and traces. Like when we go to a doctor, they have a lot of tests that can be made. Sometimes I remember when I was young, they put me kind of a device for 24 hours that was measuring my blood, my heart, the heartbeat, and things like that. So it was a kind of observability. They want to observe my internal behavior, at least from the cardiac point of view, using external outputs. I don't remember the name of the device, but fortunately everything was okay. But it was a kind of observability that were implemented for a while on my body. So it's rooted in control theory. It determines how well internal states can be understood based on available data. It's like you have a science, like you are a scientist and you want to check what's happening inside, let's say, quantum theory or something, because quantum theory is quite interesting because you cannot observe it because it alters the system. And in some way, when we implement logging, traces, and metrics, we are observing the system, but we are somehow, it was a minimal interference, but for log, you need CPU, you need storage, you need access. And sometimes people think about how much storage do I need for my data or my application, but they forget that sometimes the log takes more space than the data of the application. So somehow your observability change the internal state of the system. Observability answers questions like, why did this error occur? Okay, it's not this error occurred. That's what we observe, but we want to understand the why. What caused this latency? How is this service behaving over time? Okay. Let's see some more details. Why observability matters. Modern systems are distributed. This is one of the main reasons. You have microservices, multiple servers, distributed servers, containers, cloudnative architects, increase complexity. I mean, you have a lot of different systems with different types of logs, which one with its own metrics, and you want to find a way to collect everything, concentrate in specific places, and have a way to, let's say, understand what's happening inside the system. So you want to integrate something with your application. You want your applications to be able to be monitored and export some information about them. And then you need good systems that can integrate all this information, correlate it, and give you nice outputs, at least nice, not from the point of aesthetic, but from the point of the semantic value of the information. So the traditional monitoring isn't enough. In the past, when I started to develop it, we were very happy with logging and sometimes a few metrics, but it was too reactive because you look at the metric and you say, okay, something is happening here. So what can I infer from this? And it was very difficult to say, okay, I checked the CPU has a spike, but I didn't understand why. What was happening at the time when the CPU touched the 100%? It was the storage, it was multiple queries, there were a lot of requests, it was an attack. It's very difficult sometimes to check what was the real reason. You need more than a metric. Maybe I have logs. So now, how do you correlate the logs with a metric? By timestamp? So you have to have a good system of logs. But now imagine that you have microservices in Kubernetes and you have 10 or 20 systems producing logs. Which one of them is relevant for this metric? It's quite difficult. So the traditional monitoring isn't enough. Troubleshooting becomes faster and more accurate. So reconstruct issues post-mortem and detect cascading failures before impact. That's very difficult. So better engineering culture, empower developers and site reliability engineers. You can read from this. I think Google has a good great book. I think it's free about these site reliability engineers. It's a way to create objectives, check indicators. It's not about, let's say, observability, but helps a lot on the observability. Okay, don't misunderstand site reliability engineering with observability, but usually one of the roles of this engineering is the observability, and there are some metrics that you can create to make sure that your system is reliable. So the name site reliability engineering, and I invite you to find, I think I read this book in the past and I think it was free at the time. You go to the Google site and probably find this book. So the idea is to empower developers and site reliability engineers to understand and own their services. So why observability? Let's check from the monitoring point of view. It kind of, when you see monitoring, we say it's reactive. We detect no issues. That's one of the things. So you have a monitoring, you have some metrics, you look into it and say, okay, maybe the problem is this one. The observability takes a different approach. It says it's proactive, explore, and knows, because it receives all this information. Of course, you need good tools, and I will talk about them in a moment. But the idea is not to be reactive. It's being proactive, creating alerts, checking, making sure that you have well-configured let's say triggers that say, okay, usually I expect to receive 100 requests, 1000 requests per minute. Now I'm receiving more, or I just receiving only 10. It's not normal. Maybe one of my servers is down. There are things that you can catch even let's say before they really start to go really bad. Okay, so monitoring fixed dashboards and alerts. It's I remember creating monitoring applications when in upfront you already know what will be the dashboard. Everything was already created. So we will monitor this, like as if you can guess what can go wrong with the system. That's one of the things of the past. Today it's ad hoc queries and dynamic exploration. We want to receive all these informations and have good tools where you can query, like we query a table of a database, but we want to query the logs, we want to query the metrics, we want to check the trace, and sometimes we want to create joins between all the information to check it when this transaction, this specific ID was happening, what were all the metrics, the logs, and the trace behind this observability or under this system. Okay, so monitoring tells you something is wrong, so we can create alerts. That's what the best today. Observability tells you why it's wrong, and this is the most important. So the three pillars of observability, and I've been talking about them. So first is the logs, it's the unstructured or structured records of discrete events. Usually every developer knows what is a log, but logs, it's more than that, and I will address this in a future video. Sometimes we do logs with a timestamp, a message, and sometimes they are not good ones. From my experience, it's not common for me to see a good logging of an application. Usually just too much default or too much information. It's not well structured. They forget to use something which is called MDC, where you can inject attributes in the log automatically for each thread that is running in your application. So you can cross later these logs, entries with metrics and trace and things like that. Sometimes people don't understand these tools, but I will address them in the future. Maybe I can, let's say, bring something new to you. And it's ideal for debugging and auditing. That's the purpose of the log. We want to debug something happened. Let's see what was the transaction ID, what was the customer. The customer said, enter the password. I don't see any password here. Maybe in the log there is no password, but at least you can create an hash from it or hash from half of the password so you don't put in danger the security of your application, but you can check the logs for that. Now you have the metrics, which is the numeric data over time, like counters, gauge, histograms, ideal for trend analysis and alerting. I think it's self-explanatory, the metrics. It's quite useful. What is the CPU? How many requests? How many logins between these are? For instance, in a normal system, you expect the number of logins in an intranet to be very high, between 8 and 9 in the morning, and probably between 5 and 6 afternoon. but at 11 o'clock or 3 o'clock, it's not normal to have too many logins and logouts of the system. So you can create alerts around this kind of concept. Sometimes people, they just put a number, but they forget other dimensions. Logins, for instance, you want to create alerts for specific hours. You can say, I expect 1,000 logins in 1 hour between 8 and 9, but I don't expect 1,000 logins between 10 and 11. Maybe it's an attack. It's the same monitoring, the same alert, but can have a completely different meaning just based on the hour. And that is quite important to understand how to create good metrics and to create good alerts based on metrics. Sometimes people focus just one dimension, but there are multiple dimensions that are as important as the one that we start. The traces represent end-to-end request flows across systems. I can give you an example. Sometimes people misunderstand trace with logs. Logs, it's about auditing, debugging the application, something that happens in the code. The metrics measures something outside the code and some internals of the code. Maybe you want to count things that happen inside your application, and it's quite common nowadays. This, and then you have the traces. Trace is something like, let's say you are doing a checkout, and you say, okay, this user start the checkout, and there is an event. Maybe you want to put some information and aggregate some metrics and logs around this, and you mark this as a specific number, which let's call it trace ID, and you want to associate this ID with the logs and the metrics. You add this attribute to all this information. And observability, it's about this. Now, the checkout, let's say you count the number of items, you check the value, check the storage, the warehouse, about if they exist or not. It's okay. Now you ask for the credit card. Now you the contact, and each one at the steps. Usually inside the trace, they are called spans IDs, but I will talk more about this in future videos. And you have this span IDs, something, let's call it as if you have a transaction. Now you have sub-transactions. So you want a trace from the start of checkout until the let's say the order that you are creating is sent. So you want this all ID to be aggregated. So if something happens, and you are collecting this trace to a specific place, this transaction information, then you can, when someone, okay, I receive an email saying that the order was being sent, but I didn't receive, the number seems wrong. I ordered 5 items, but only 4 are here. Now you can cross, due to this correlation IDs that you create on the trace, the metrics and the logs associated. Maybe you find in the log associated with this trace saying something, okay, product not found, for instance, in a database, or you are connecting to a microservice or something like that. So these are the 3 pillars of the observability. Remember, logs about application, metrics, it's about numbers, trace, it's about, let's call it a transaction that happening, not transaction as a database, but transaction from the human point of view or system point of view, something that it starts and you want to end at some time. Let's say, for instance, in a system that like Teams or Zoom, a trace would be something like start the call, check the quality of the call, some metrics, some logs about what is the user, things like that. So now measure the call, start the ringing, now finish the ringing, someone answer, a user enter, event 2, event 3, another user enter. Now there was some sharing screen, and then you have all these spans until the end call. And you measure the time, you measure on number of people. So you have metrics, you have logs, and you have the trace with a specific ID that you can correlate with the others. This is the 3 pillars of the observability. So main components of an observability stack, if you want to implement, one is the instrumentation. Instrumentation, it's about collecting data, collecting all this data and concentrate in a specific place. And usually you can use something like OpenTelemetry. And if you are interested in this area, I will advise you to start in this. It's quite comprehensive. It's very nice. It's free, and most of the popular systems, they support OpenTelemetry. We have SDKs and things like that. And my next video will be a starting implementation using OpenTelemetry. But there are other tools like Micrometer, SCL4J. I know this is about logging, but it can integrate quite well with OpenTelemetry, for instance, for attributes, MDC, and things like that. Exporters, so where to send the data. You can send to using a protocol which is called OpenTelemetry, like this one. And this protocol allows to take telemetry from, for instance, Java application, Python application, and other languages that are supported, for instance, on OpenTelemetry, and send to some place to files, to a collector, for instance, a collector, I don't know, like this one, OpenTelemetry collector, that can aggregate data, supports as an input this protocol, so it can receive data, for instance, from a Java application, collects the data, and then you can do whatever with it. Maybe send to a database, send to a file, send to a Prometheus, to formatics, but I will explain in a moment the common architecture for this. So you have these exporters, you have the collectors who receive the information. You have an OpenTelemetry collector, which is free. You can just take one as a, like say, a Docker image and play with it. It's very simple to work it, and you can see quite fast how does it work. FluentBit, it's another one that's quite popular. And you have storage systems like Elasticsearch, great for logging. Loki, also great for logging. The difference between two is Elasticsearch index everything. Loki only index attributes that exist in log. They say that a lot of people prefer Loki over Elasticsearch because it's fast and quite simple, and it doesn't need to storage too much because it doesn't index all the logs. And at the end of the day, do you really want to search every word that exists in a log, or maybe just important attributes like which application, timestamp, the number of the transaction, the user email, and things like that you can define. Prometheus, it's quite clear for it's a timestamp database, a time series database, not timestamp. Time series database, Tempo, dashboards. Now you need the dashboards to see everything that these tools can aggregate and see it in place, usually Grafana and Kibana, and alerting and notifications like Alert Manager. Grafana can also provide alerts. For instance, Prometheus can also produce alerts. But let's see in a moment the architecture to understand better the relation between all these components. So let's see a common application. If you want to implement one, imagine that you have a front end or a back end. You don't have to add both, but imagine that you have a Java application, quite simple, or maybe a back end, a Spring Boot application, and you start with OpenTelemetry. You can add OpenTelemetry SDK, just a Maven dependency or Gradle dependency, as you wish. And this allows you quite fast and easy with very simple configurations to start to export data, okay, using the protocol OTLP. It provides other kinds of protocols that you can use, but usually this is the most popular one. Now you can create a collector, and the OpenTelemetry already contains one, but there are other tools that can work as collector. For instance, Jaeger can also work as a collector. Directly supports this protocol here. But if you want to follow this architecture at the start, you just create, let's say, a Spring Boot application if you are a Java, but any application. I already tried this with other language. For instance, Python also works. Use an OpenTelemetry SDK. You export logs, trace, metrics. It's quite simple. The API is quite simple to OpenTelemetry to work. The collector receives, and then inside the collector, I will explain this in my featured video, you have a kind of input, then you can have a processing, let's call it transformers, that can transfer the data and export. You can just take input and output, but you can create a kind of internal pipeline where you can transfer this information. You receive logs in a format, and maybe you want to produce a different format, or you just want to ignore and completely bypass the insides of the collector, but it works as a pipeline. So in this way, the data that is received from any application here can be, for instance, if they are metrics, they can be exported to Prometheus. If they are traces, to Jaeger, and Elasticsearch can receive the logs, and you can work with all of them. Of course, it's not that you have to use Prometheus, Jaeger, and Elasticsearch to have observability. This is just one of the examples that are great tools that you can use. These ones are free, but there are paid tools that are really great for observability. But usually these three can do a great job. I know Prometheus is free, Jaeger is free, Elasticsearch, I think if you install local, is free, but probably you need license if you want to more than one server. But you have another one, like for instance, Grafana Loki, that probably we'll see in one of these slides, that can do, I wouldn't say the same as Elasticsearch, but for logging, maybe it can. At least it can do enough. So, and then you have the dashboard. So even Prometheus contains a dashboard, but in Grafana you can do it better. Grafana is a very well-known application that can, it has a kind of connectors that can connect to Prometheus, Jaeger, and a lot of other systems, and you can create nice graphics or list of things, create alerts and things like that. And you have Kibana, it's a kind of a Grafana, but for Elasticsearch. So this is just a quite common architecture when you need to use observability. Observability will be about this lower part. your application will be here, and you need OpenTelemetry SDK. You can see it's almost an infrastructure, but it's really important to have observability. So common use cases, incident diagnosis. Why did checkout fail for this customer? It's not easy to start to search logs. If you have something like this, it will be better for you, and it will be easy to find. For instance, if you have traces and you play with this tool and then invite you to do so, it's quite simple. If you have traces, you can see there is a nice dashboard with the time, and you can just go there and check what was happening in that day, what traces were being processed, and probably it will be quite fast to find the checkout if you create a trace for it. Latency troubleshooting, visualize service bottlenecks via traces, for instance, and because again the trace follows the whole transaction, and maybe you see, okay, at this point it seems to become slow, and you understand it's the second and third part. It's when I receive the request, then it goes to this system, this transaction. I'm trying to contact the warehouse, and it takes 1 second to answer. Maybe the bottleneck is here because it's taking too much here. And these kind of tools, even Jaeger, they are not great in dashboards for the visual point of view for these metrics, but it contains some metrics, and you can detect quite fast, let's say, outliers on the traces. And resource optimization, identify memory and CPU spikes. Security auditing to analyze logs for suspicious patterns. Sometimes people don't do it, but they should. You receive logs, let's say, with simple things like login. Let's say we have an info log. Let's say someone starts a log and then finish the log. And imagine that it's a two authentication, or every time there is a login, there should be 1 or 2 systems contacted for the login to be successful. In that case, make sure that at least not for all of them, but create a kind of a way to check the logs and do a kind of a unit testing on the log. It's called fitness functions, by the way, but you can use a kind of a unit test on the log that checks randomly once in a while to see. Let's see if all the steps in the log are being applied. Because if they are not, and the user still logs in, maybe you have a breach in your security. That's one way to use this kind of information. And SLI and SLO, tracking metrics feed in reliability objects. SLI and SLO, it's very related with the site reliability engineering that I previously talked. If you read the book, you'll understand this is a service level indicator, and this is a service level objective. Let's say the I indicates what is the current value, and the O means what is the range acceptable for me, what is the number that I'm looking for, how many requests I expect, how many logins do I expect between 8 and 9, let's say between 200 and 700. But between 10 and 11, it's a different range, maybe between 10 or 0 and 100. If it goes out, meaning if the value it's outside of the bounds of this SLO, I should throw an alert. But sometimes it's not a range, it's maybe just a value, for instance, maybe true or false, good or not, system is online or not, something like that, or it was successful or not. But these are, let's say, names to identify the metrics, numbers, values, and the objectives. Okay, a step-by-step plan to where to start if you want to start with observability. First, learn from it. Maybe wait for a few videos on my own if you don't want to read a book, or just read a book and some information about it. So start small, instrument one service with OpenTelemetry SDK. Usually when I'm doing OpenTelemetry, I'll start with a simple thing like logs or metrics, depending on the customer. If the application already contains logs and it's simple application, maybe I should start with the metrics, because metrics sells well. If you expose numbers to a customer, he likes to see the numbers. How many calls, how many items, how many checkouts, things like that is quite nice. It can be a good way to check if the system is okay, and at the same time it gives sometimes some semantic or business information. But if you need more from the technical point of view, start with the logs, test it, implement all the infrastructure for the logs, then go to the next one like traces. It will be quite nice, the traces, identify the traces that are the best for your solution, and go from there. Then deploy a collector to receive all this information. OpenTelemetry collector can collect these 3 types of the information: logs, metrics, and trace. Choose your backends, Prometheus or metrics, for instance, Jaeger for trace, Loki or Elasticsearch for logs. There are others, but these ones are probably popular, free, and you can even install on your machine. and test them. In one of these days, I had to create a presentation about OpenTelemetry, and I execute everything. I had a Spring Boot application, a Prometheus, a Jaeger, Elasticsearch, a Grafana, a Kibana, and Open Collector, everything. Of course, it was a big Mac with 16 gigabytes of RAM, but it was possible just using containers. Okay, build useful dashboards, track latency, error rates, throughput, alert on meaningful conditions, don't alert on noise. That's one of the problems. Once I was working for Microsoft, and one of my responsibilities was to check a monitoring system. I think it was COM for Microsoft. It was a lot of years ago. And one of the things that was wrong in the company at the time is that too many alerts. They want to monitor everything, and the values were quite strict, so a lot of noise. Most of the alerts that were being thrown were not useful. It doesn't mean that the system decided to had a problem. It was just the person was too paranoid. And sometimes it's better for you to have just 3 or 4. But when they appear on your system, when a red flag appears, or a specific email message, you want to see it. But if you receive 100, at some point you say, okay, it's always the same. And one day there is 2 or 3 that are important, and you don't check them out between all the noise that exists. So be careful with that. Avoid premature complexity. Start with core components. Always start what is the most important in a system, and start small. It's better to compare with small things and improve, or maybe throw away to create bigger things, and then we have, okay, I did all this work, I don't want to refactor everything, and the system will not be a good system because of that. Start small, use the agile way in everything. Common tools by category, if you want for your reference. Logs, Loki, Elasticsearch probably are the most popular. I see a lot of people talking about FluentID and FluentBit. Metrics, Prometheus, it's really popular. This one I already saw a lot. Micrometer, Graphite, StatesD, Trace, Jaeger, it's quite popular. It's free. Zipkentamate is also popular. OpenTelemetry Collector. You can use OpenTelemetry Collector here, but OpenTelemetry Collector will be more to get the traces and send to Jaeger. You can put on some files and export yourself, but if you want a good site, probably in the trace, you connect using OpenCollector and send to Jaeger. Even Jaeger can receive directly as a collector if you want. Storage, Elasticsearch, Temp, Mimir here. Dashboards, Grafana, Kibana are quite popular. Alerting, Alert Manager, Grafana Alerts, PagerDuty. There are others that are better than these ones, but most of them are paid. Okay. Lifecycle observability, again, our architecture. So we have here our services, application service that sends something to a collector. OpenTelemetry is a good one, but again, you can pay and have a different one. For telemetry backends, Prometheus, Jaeger, and Loki, or I didn't put here Elasticsearch because Loki it's a good alternative, and it's from the same company as Grafana, so they talk really well each other. And Kibana here, okay, you can use, but usually Kibana, it's more linked to Elasticsearch. Okay, usually probably with Grafana you can do everything, and you don't need Kibana. It depends on the system that you are connecting Kibana with. And of course you need some alerting system, like Grafana Alerts, Alert Manager, or maybe one custom made in your house that checks. Prometheus can even throw some alerts. You can create some alerts here and notify someone, DevOps team or engineering, site reliability engineering, or whoever are the persons in your company. And then when you receive the alerts, you will check probably the dashboards to check the information Kibana, and sometimes maybe you want to do some queries inside these tools. By the way, Jaeger can be also a kind of a dashboard because it contains a good visual for you to explore information. So key takeaways about this subject: observability empowers fast diagnosis and continuous improvement. Okay, logs, metrics, and trace together create a holistic view. You need all these three to really take the internals of a system. And again, start lean, start small, start solid, start with the most important on your system, what you really want to check. If your system is about selling, maybe you want to check logins, authentications, and sellings, how many, if everything is okay, what is the success status, what it means to be success in your logs, what it means success in your metrics, what it means success in your trace. Make sure you have metrics for that and start from there. Make observability a development practice, not an afterthought. It means that, for instance, I am in a project and I'm involved in OpenTelemetry also, there on the telemetry, and we are introducing now when the applications are being started, not at the end. Because sometimes you have to adapt the code or create the code or the architecture to fit the telemetry. Otherwise, it will be too late, and you can have telemetry anyway, but it will not be rich enough for you to take real advantages from it. Okay, so what's next? Integrate OpenTelemetry in your next service. Try it. Check OpenTelemetry docs. Just read it. I will explain in more detail, and I will do some, let's say, applications, small applications on OpenTelemetry. We'll see this work. We'll see metrics. We'll mount a complete system in my feature videos. I will promise you that I already did in the past, so it will not be difficult, and it should be easy. I not decided yet if I'll create a big video with all the building. Maybe I will, or maybe I will present each one of the tools, maybe in agile way. At the end, we have a system. We'll see what is the best approach. I don't like videos with 4, 5, 6 hours. Sometimes they are great, they work as a course, but other times I like to, for people when they came here, to say, let me check how to work with Prometheus. And then the video explain Prometheus, integrate on telemetry, so but the focus will be on that tool. If you want to have more broad focus, you will lose something in the explanation. We'll see. So drop a comment if you have some ideas on how do you like to see the next videos. Correlate trace with logs for powerful root analysis. Automate alerting based on real service level agreements. So observability is not a tool set, it's a capability. So thank you for watching this. I hope this was educative for you. It was a good introduction. I will, my next videos for sure will be practice, some theory probably at some point. I like to present some theory so people understand the concept and the paradigm behind it. If you understand the why, it will be easy for you to implement. I don't like to show just how to implement, because sometimes don't understand why was decision taken, why is doing this connection, why is doing this configuration, why this system is here and not another one. That's why I like to always start with a theory. But again, as I said previously, I will create for sure practice around this. So my next episode will be introduction to OpenTelemetry, and we'll do some telemetry probably in a language like Java or similar one. So thank you for watching this video, and I hope to see you in my next ones.